Good morning, everyone. My name is Tyler Hoeven. I'm an ecosystem engineer at the Stellar Development Foundation. My job is to funnel to build educational programs and initiative to onboard developers into Stellar. By show of hands, who here has ever written a single line of code for the Stellar blockchain? One of you, yeah. So I've got job security. I've got a lot of work to do. No, but seriously, I get it. What is Stellar? It's a kind of that dinosaur chain that just won't die. Stellar actually predates Ethereum. It's been around for ages. Well, let's not kid ourselves. We're all here for ETH-den, not ST-den. I attribute this perceived lack of adoption to two critical points. Stellar is a purpose-built chain. It's not for anything. It's not aiming to become a mesh network of arbitrary compute. It's for value transfer, and specifically value transfer for those on the fringes of equitable financial access. Financial access for everyone. This limitation is served to focus our scope to practical, real-world, immediately relevant use cases, things that are less flashy, less newsworthy. But that's for folks that, maybe most of these folks in the room don't necessarily have that problem. We have access to finance. We have bank accounts. So we don't struggle with this problem. We're developers. We love new, flashy, innovative technology. And this rift, this divide is what causes this problem. It can be a significant issue to have amazing technology for the world that developers don't necessarily need. It doesn't solve a problem that they immediately have. But today I'm going to be talking about Soroban. This is our new smart contract protocol attached to a plugin onto Stellar. Stellar is a limited, it's not Turing complete. You can't do anything on it. It's got 22 different operations, payment-oriented operations. But last year we made the decision to add Turing complete smart contract protocol as a sort of plugin on top of the Stellar blockchain. And that's what we're going to be talking about today. Well, what is Soroban exactly? It's as I mentioned, a Turing complete protocol. We're adding it alongside the Stellar blockchain. It's not a new blockchain. It's sort of this super tool extending the innovative interest for Stellar. So from these 22 specific types of operations, you can now move into this infinite scope of who knows what you want to do. But one thing I'd really like to point out is that this is not a new blockchain. One of the difficult things or hesitations developers might have towards approaching a new piece of technology is who's there? Where's the liquidity going to come from? Where's the money? Where are the users going to come from? That's what makes Soroban really, really interesting is it's tacking on already to an ecosystem that's filled with assets, filled with liquidity, already has developers. It's very use case oriented, but now you can get immediate access to all of the assets that are already on Stellar directly inside of Soroban, which is fantastic. But I'm here to talk about you and where you bridge this gap between what we have in Stellar and what we can now have in Soroban. And that's where we come to our opportunities for developers to make money. We have $100 million set aside for Soroban adoption. And this is specifically aimed towards developers to test, use, explore, build different applications, test it out as we build Soroban. We have three right now that I want to draw your attention to. The first one, you can kind of see we've got these three different ones at three different price points, if you will, of engagement. The first is very strictly just education. Soroban is a Rust, WASM-based blockchain. Rust is infamously enjoyable to learn. So we're working on making sure that onboarding experience is enjoyable, fun. That's where I spend a lot of my time, this application called Fast, Cheap, and Out of Control, where we're going to learn to build Rust, we're going to learn to build contracts. The things that you learn there will be applicable to anywhere you might decide to take your Rust knowledge. I think all of us hopefully can begin to understand that Rust is valuable, it's useful, something that we can take anywhere, not just blockchain, but it's not a ton of fun to learn. So Fast, Cheap, and Out of Control is a great place to kind of onboard into that ecosystem. Sorobanathon is where people that maybe aren't looking to start a startup or a company, but want to write articles, want to do comparative analysis. Maybe you're into the EVM or Solana, Near, and you want to just compare. What does contract size look like compared between these different chains? Write some articles, maybe do some demos. You don't have to start a company. We're giving out money for people to just do open source documentation, repos, things like that. And the last one is the Stellar Community Fund, which is where we're giving out upwards of 150 grand to build up small startups, to have ideas and implement them and ship them out into the world. So those are our 3 different opportunities. Those are the ones I really want you to keep an eye on as you think how you might like to engage with Soroban. So that's the website for Fast, Cheap, and Out of Control. If you want to write that one down to start learning Rust and Soroban, it's a nice retro game. It's a difficult math problem. It's a load of fun. It is Rust, but I think it's fun. Next one's Sorobanathon. That's the one you're going to want to write down for writing out articles, repos, different public-facing information. And then last, the Community Fund. All right, but we're here to talk about code. I'm going to be honest with you, though. Smart contracts aren't new. So I'm not going to try and blow your mind. I'm not going to try and impress you with our amazing smart contract protocol. It is incredible, but I'm going to leave that for you to decide, right? This is not new. We're not going to pretend like we've invented something that nobody has done before. So as we go through, I'm not going to try and really impress you with a lot of its features. There are some incredible things, but my goal here is really for you to try and open this up, play around with it yourself, and make these decisions based on other chains that you've worked on, protocols, etc. We're going to start our journey here on soroban.stellar.org. If you forget anything else that I say, make sure you write down soroban.stellar.org. This is our documentation site. It's our router for all of the other sites and funding opportunities that I've mentioned. This is where we're going to learn how to set up our environment. A lot of our examples actually open up into a Git pod environment, so if you're having trouble setting up your Rust environment, or you don't want to install a whole bunch of stuff before you make a decision whether or not you want to go down this road, we've got a lot of easy to open Git pods. Let's do a classic Hello World example. This is inside of our documentation. I'm not going to do anything too live. I've had enough fantastic experiences trying to do live things, so we're just going to kind of walk through. Again, the goal here is to kind of get you familiar with what the experience feels like, what it looks like, with the goal of you trying it out. All right, so this is just a really basic Hello World contract written in Rust. You can see up at the very top. Who here, has anybody written Rust code before? Done anything with Rust? We got a couple. Okay, so the first thing you're going to notice right up at the top is we're excluding the standard library. So we're taking a very opinionated approach to not make things as easy as possible, but to make them as secure as possible. Now, there is a lot that goes along with that in the SDK layer inside of Soroban for things like authentication. But right off the bat, we're going to be throwing away a whole bunch of code to ensure that our contracts are small, they're very efficient, oriented around these payment transfers, getting rid of all the stuff you might accidentally make mistakes with, and then we're adding on top through our SDK and our environment, all the stuff that you're going to need to write good, solid, safe contracts. But this is pretty small, but let's be honest, that's a Hello World contract, not that impressive. This is a test. Soroban is Rust end-to-end. It's just Rust. So you can do basically everything, the development of your contracts, the testing of your contracts, all within Rust without ever having to touch a chain, without ever having to do anything on a local environment or a test network. You can do all of it right inside of Rust, which makes things very fast, very easy to toggle and test things between the different environments. You can load up your environment with different parameters within a ledger to test certain variables, scenarios, but you just write loads of tests and then can assume, or you can be assured that whatever you see happening inside of your tests is what will happen on the network, because we run Rust on the back end as well as when we're actually developing our tests. But Hello World is boring. Let's do something a little bit more interesting, like a cross-contract call. We'll develop that was our Hello World example. We'll just build that out really quick. And then we're gonna import that contract into another contract. You'll actually notice we're not even building another contract. We're just doing another test. We're gonna pull in this new contract that we deployed, that we compiled. You can see this happening in the mod client where we just pull in that previous contract that we built, and we're going to get the interface for it. If you look down closer to like line 14 where we call client.hello and then pass it in the argument, you can build up these contracts and do these cross-contract calls even though we're not even using a network. We just wrote another test to see what would happen if we did a cross-contract call. You get access to all of the functions and methods inside of that contract. So development is very easy. But that's still boring because that's still a Hello World application. But I really want to kind of, from what we've learned so far, we're gonna dive into tokens. So one of the things I mentioned is that Soroban's not a new chain. And so what that means is that you get access for free immediately all of the assets that are already on Stellar. Okay, we don't have to bootstrap that whole ecosystem of assets. We're going to get to pull all of that in through a native token contract that exists on the Stellar Soroban side. We'll import that in the similar way that we did this. We'll import that interface and then make use of it. So that's going to be our next example. If you haven't seen a lot of Rust, I apologize, but at the same time, you should be encouraged that it's not that much. Because we get rid of the standard library, a lot of the stuff that's hard in Rust becomes very easy. There's just not that much to it. Look at that, a passing test. That was nice. Okay, so there's our token spec. Let's take a closer look. If you look up at the top there, you can see we're pulling in, just like we did in that last test. We're going to build a new contract, or I guess it's going to be the same contract. We're just going to add a new function called faucet to it. We're going to pull in this token contract spec up at the top. This is a token spec that Stellar has built for Soroban that will allow you to tie between Stellar assets and Soroban. So any asset that exists in Stellar, you can begin to pull it straight in. Things like USDC and other stablecoin type assets that are already existing, already have liquidity on our network. Let's take a closer look. It's quite simple. We just pull that in. This is our faucet function. This is I'm going to be honest, this is kind of a useless contract, but it's giving you the idea that you just don't need a lot of stuff in a contract to begin to have something that's very valuable, very powerful. There's no wrapping involved here. It's the exact same asset between Stellar and Soroban. Right, we're just going to pull in a token ID, which for our cases, we'll use the native XLM token. There'll be a from address, the to address, and then how much we want to transfer. So it's really just a proxy contract, if you will, that's just going to pass assets between one address to another. You can see on line 8, we've got a really interesting way that we're doing auth. If you've played around with the EVM or other contracts, you might have seen this like borrowing authentication where you take whoever signed the transaction and submit it to the network. You kind of borrow that authentication and make use of it inside of the contract. We've taken a bit of a different approach where you actually have to be much more explicit about what address do you actually want to authenticate? Which one do you want to ensure, and under what parameters, what message do you actually want them to sign when you're authenticating it? So you can pull in any address, you can build any sort of authentication structure that you want. This is actually this is incredible. If you've spent a lot of time trying to fiddle around with auth, this is a very new, very innovative paradigm. One of the advantages of being so late to the smart contract game is it does give you this opportunity to learn from the mistakes and challenges that other chains have faced over time and to rebuild kind of from the ground up something that would have solved for a lot of that. And this require auth, this rethinking of how we do authentication is one of those things. Then we simply pull in that client contract from what we imported above. We can call this transfer method on the token client, and then we're just going to output this argument that's going to give the new balances from the from address and the to address. Let's look at a test. So our faucet function looks a lot like, our faucet test rather, looks a whole lot like our previous one. You can see all of these helper functions that we have available to us that come right from the environment. So you can pull in addresses. You can see we're registering the Stellar asset contract up there on line 8. We're going to mint some tokens, similar to what you might have in like a friend bot. But again, this doesn't happen on a network. So if you have these helpful tools that VS Code makes available to you, you can run these tests right inside of your console. They run immediately. You don't have to do any deploying. Everything works just like it would on chain, but it's just very, very fast. Because again, Rust, end to end. We're just going to run through that, do a starting balance, have a couple arguments, and then do an assertion there after we do the faucet. We can run this test all very quickly without, again, having to deploy anything. So we would build that. Okay, so that was interesting. Again, that was just a Rust test, though. What if you actually wanted to deploy to a network? Well, we have the Soroban CLI, which makes this very, very simple. We've done a lot of work to make sure that the CLI experience is quite good. We're going to go ahead and do that here as an example. You can see up in the top there, we're going to generate some identities. So you don't have to pass a whole bunch of flags. You can set up these identities within your CLI, which makes it a lot easier to keep track of addresses as well as networks. We'll get the public keys for all of those identities that we generated. Then this long curl request is basically making a call to our actual network, our future network, to fill all of those accounts with actual balances on Stellar, so that we're going to be crossing the Stellar Soroban side. That's kind of what we're doing in this demo, is going to cross the Stellar Soroban divide here. And on Stellar, unlike on smart contract protocols where your address can kind of just exist and you can do anything you want with it, on Stellar, the account actually needs to be funded. And so that's what we're doing here, is we're calling the friend bot to create those accounts on the Stellar side so that we can actually have some lumens, have some native token to do something with those. I will note that this is going to put 10,000 XLM in each of these addresses. So further on, when we look at the transfer, you'll notice that there's a large balance. Because what actually happens is there's 10,000 XLM, which is 10 million of our smallest unit. So don't get thrown off when you see a large balance later on. We're putting 10 million of these, what we call stroops, small amount of XLM, into all of these addresses so that they exist on the Stellar side, so that when we call the Soroban contract, that transfer will happen without you having to do any wrapping or unwrapping. It all happens by itself. All right, we'll add our network. It's just an RPC endpoint and a passphrase. Then we'll deploy that contract. So this will actually get it deployed to that network that we just set up, to that identity. Look at that, success. Didn't have to use Wi-Fi. That's our hash address right there for our contracts. That's what we'll use further on down the line when we do an invocation. You can see we're invoking down there on the function line. We're just going to invoke first that hello function. We'll pass it the world to the to argument. And we'll get that output of hello world. But that was the boring one. That's hello world. Let's do the token one. That's what it looked like if you were passing, now that we have that deployed contract, you'd pass in the ID, the identity of from, the network, FutureNet, pass it to the function, the faucet function. That token ID, that's the ID of our native contract that exists on the actual FutureNet. Pass it the from address, the to address, and the amount. And then just like we had it on the output of that faucet function, you can see the 10 XLM have passed from the from address to the to address. You can see that you've got those 10 billion from the friend bot. But that's kind of interesting that you can pass between the Stellar side to the Soroban side without having to do any wrapping. And you could do this for any asset that exists on Stellar. All you have to do is wrap up that, deploy one of these token contracts for that asset, and immediately if there's 10 of that in Stellar, there will be 10 of that in the Soroban side. So there's no bootstrapping of the network. It's already existing within the network that we already have. Just now all those assets, instead of doing only 22 operations, you can do anything you want. Here we are looking it up on the FutureNet, just doing a curl request to that account, the to address, and you can see those 10 stroops that we transferred from the from address to the to address. All right, so again, the goal here isn't necessarily to impress anyone tremendously, right? We're not new to the game. We are new to the game, but the game's been around for a long time. So my suggestion, my request, is to poke around with it. Try it for yourself. Get into our documentation. Try the fast, cheap, and out of control. see how you might want to engage. Again, we're going to hit mainnet later on this year. We're not at mainnet yet. So there's a Play-Doh protocol. If you've ever been playing around with a smart contract protocol and wished you had been there in the beginning and could have influenced the design of a smart contract protocol, now's the opportunity to do it. And not just to do it, get paid for it. We've got plenty of grant money, that $100 million over the next few years to disperse between developers that are building documentation, exploring, finding issues, making requests for things that they would like to see, employing your experience that you've had across other protocols, and helping us to develop a new one, and then also to write documentation and comparisons, repos, demos, to bootstrap this ecosystem, and then obviously for those that want to build startups, try your hand at changing the world, the Stellar Community Fund, where we're giving out larger grants. Again, if there is a website to remember, it's soroban.stellar.org. Make sure to write that one down. And thank you very much.